engage in a bit of reflection, okay? Specifically, I want to talk at a tiny bit of a higher level about effective strategies for using hybrid models, and point to a final hybrid, well, one or two hybrid model strategies. Can anyone riddle me that? What are the two strategies we've seen thus far? System dynamics and agent-based. Well, okay. So those are 2 points on the modeling spectrum, but how find them in a hybrid way? Well, one thing we've done is like this. We had these agents in the population, and they drove the flows of a model. When did we see that? I'll give you a hint. It was less than 24 hours ago in this very room. And it occupied us for the first part of yesterday afternoon. What flows were being driven by agents in that model? They were flows associated with costs and qualities. Remember that? In life years lived, it was totaling it up across the population. Remember that? How could we forget, right? Okay, so that was one type of modeling. A second sort of modeling, and I stand before you most remiss here. I'm going to need to sudden and go seek the solace of my Linux side here, because I know I have some slides of it here. This is going to be a glimpse of things to come. We have system dynamics within agents. That's what we just saw, right? We have system dynamics, stocks and flows within agents, describing continuous dynamics. You can imagine similar stocks and flows, very theory grounded, for things like weight change, body weight composition change, and people's weight. And there's some beautiful models out there in the literature, all sorts of physiological processes that you could capture in this way. Kevin Hall's model from the NIH has been calibrated to data from volunteers, study participants, and weight in chambers where they measure with exquisite detail all their energy intake and expenditure. They use the air collected to analyze it into carbon dioxide, etc., to understand energy expenditure. And they're very theory-grounded models of body weight change, etc., that can be tied in with agents. These are very powerful things for asking certain types of questions. So we've seen kind of these two examples. What we're now going to turn the purpose, the enterprise to which we'll now turn our attention is no less to examine a third type of modeling. A third type of modeling that goes by the unlikely name of budding. In this model, we again have stocks and flows. But these stocks and flows, rather than being driven by agents, and rather than being embedded within in driving the dynamics of individual agents, here, the stocks and flows on the one hand, and the agents on the other, form a lateral relationship. In other words, they're at the same level of abstraction. People start in a general population that's only depicted at an aggregate level, and they are represented just as a number in a stock. Perhaps there's 3,256,281 people in this general population. They're just a number in a stock, an anonymous number with little in the way of distinguishing features. Perhaps we've stratified it by age, sex, and ethnicity, but that's about all. They have no history. They lack a network context. They're bereft of spatial location, and they live up at this point. But then they proceed in a risk continuum, and at some point they reach a level where they become a focal interest for our research questions. And rather than shoehorning everything into either all into system dynamics with its admirable lightweight character for simulating quickly and with an economy of mechanism large populations, but which suffers from a lack of precision and fine-grained resolution for certain key things, rather than forcing it all into system dynamics or all in a model, all into an agent model. We'll weave them together. Weave them using the agent model to zoom in, as it were, on the subpopulations of interest, perhaps distinguished by their evolution in a risk continuum. And sometimes perhaps some of these individuals go on, think about diseases which may be based on risk factors prevalent in early adulthood or adolescence, and they go on into society in a way that they're of lesser risk, and they might go back into numbers and stocks. So we can have extra resolution when we need it, capture networks, capture spatial context, capture agent history, capture aspects of individual preferences for this subpopulation, but the rest of the population, there's no need to simulate them at an individual level. There's no need to trouble ourselves with the data collection required to do justice to their dynamics. A powerful combination, and one that applies to many research contexts. So with that background, I would like to put before us the challenge of creating such a model. Are you up to it? Okay, let us proceed. So, we'll leave the comfortable confines of Linux and return to the world of Windows. Okay, great. So, unfortunately, the YouTube visitors won't have seen that presentation, but they will have heard the injunctions that accompanied it. Great. So let's go back to our model, and let's now save this model again. We've already augmented it with dynamics. Let's call this version 3. We want to call it a different version. Okay, ladies and gentlemen, let's take stock of what we've got. Here we have a population characterized according to two notable comorbidities, some related to weight and weight dysfunction, such as obesity, and the others related to diabetes. If we were to try to divide this population up into categories of lowest risk, which individuals here as a category might be characterized as quite low risk? Normal and underweight individuals, right? When they become overweight, they become of concern, to be sure, and they start accruing perhaps some allostatic load. No, but while they're normal and underweight, they're kind of only modest interest. So, ladies and gentlemen, I would like to propose to you that we create a version of this model where we have a general population of normal and underweight individuals, and then when they present with overweight, we'll individuate them. We'll turn them into agents. But before that, they'll just be numbers and stocks. Is that okay for you? Okay. Now, like much of this boot camp, I'm flying by ear here. So let's. It's not the right phrase for it, but I'm flying by my senses. Okay. So, ladies and gentlemen, let's take this model. Make sure you've saved it, and let's go create a stock called normal and underweight population. Okay? Okay. Indeed. Okay. And now let's create actually a second stock called agents, or called population to be rendered into agents, something like that. Oh, I'm sorry. Gosh, this is most. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. This should not be in person. Where should it be? It should be in Maine, because it doesn't belong to a person. It belongs to Maine. Yeah, quite right. Thank you. Thank you. Thank you, Joe. Okay, so we're going to have a population to be rendered as agents and a normal and underweight population, and then we're going to have a flow betweenst them. Okay? Okay, now I didn't separate them by quite enough, so let me drag this back. There we go. Great. Here's this flow betweenst them. Boom. And, oh my gosh. Come on. Where did you go? There we are. Okay, boom. Okay, boom. There we go. Okay, this flow will be becoming at risk. We'll call it the flow. Right. Right. Yeah. Okay. I'm just trying to think how I mesh it. Initial value of the population to be rendered into agents is 0. The initial value for the entire normal and underweight population will be 500. Okay. $500. Okay. This is great. This is great. Okay, so, ladies and gentlemen, becoming at risk will be associated with a certain incidence rate of risk. And you know, we could age stratify the model and make it age specific, but for simplicity, I'm just going to say incidence of overweight, something like that. And I'm just going to put it in there. Just be aware, with standard system dynamics, you could turn this into something which varies by age. I just don't have time to do it right here because we have miles to go. Okay, so incidence of overweight, and that's going to be an incidence of 1% per year, okay, on a per person basis. And each of the people in the normal and underweight population will be subject to that incidence rate. So this incidence of overweight parameter I've dragged in will be associated with the default value of 0.01. And then there's a link from that to this becoming at risk, and there's a link from this normal and underweight population to becoming at risk. So, ladies and gentlemen, suppose there's a population of size 1,000. And suppose each of those people in that population has a 1% chance, probably 0.01. per year of becoming overweight. We have 1,000 people at risk, and they each have a 1% chance per year of becoming overweight. On average, how many people will become overweight in that next year? 10. And where did that 10 come from? Whence did that 10 come? That's correct. From whence did it come? 1,000 times 0.01, right? Each of those 1,000 people is subject to this chance, this kick at a can of 0.01, this probability. So on average, right, on average, we have here a succession of trials, right? Each are characterized by a Bernoulli process. So we have a binomial distribution. The mean of that is going to be the number at risk, n, times the probability p, right? So the formula, this is again bread and butter for system dynamics. The formula here is going to be, this is called a first order delay, normal and underweight population. That's the name of the stock. Don't mess it up with the normal and underweight, which is the name of the state. It's normal and underweight population that we created just here, times incidence of overweight. Okay? Are people feeling comfortable with that? Characterize your degree of discomfort.
Does that figure out by itself that's happening every year?
Sorry?
Does it just know that that happens?
On a per year basis, yeah. That's because the time unit is year. It says incidence of overweight is 0.01. It's a hazard, a per year hazard, a chance per year. You can think of it as in continuous time though, and so this is what's called a flow, and what a flow measures is actually number of people per year, the rate at which people are going over per year. It's kind of like liters per minute flowing into your bathtub. It's some rate. So it's a rate in the sense of sort of number per year that are flowing in this flow. So if the flow's rate were 10, that would mean 10 per year. Okay? That's what the meaning of that flow is. And that's why the stock is the integral of the flow. So, this is the rate of change of this population to be rendered into agent stock. So 10 per year means we'll be going up at 10 per year, the stock will be. Okay, are people comfortable with that? So what did I do? I've created two stocks, one with 500 agents, one with 0 agents. I went to this flow, and I put the formula for it to be the value of this stock, the origin stock, times this parameter. People okay? We're actually most of the way done. Now comes the wee uncomfortable bit. Are you ready? Okay. Your breakfast is digested. You're ready. You're ready to roll. Okay, great. So, ladies and gentlemen, I would like to add in a most unlikely addition to this model. It would be as if I asked, as if you asked me to make an omelet, and you saw me mixing in, I don't know, the hair of a toad or something. So the hair of a quokka. The tail of a bilby. Okay, so ladies and gentlemen, I would like you to go add in an event. And this event will be called no less than create agents trigger. Wow. This is unfamiliar territory. Much as to this North America denizen, much as are the noses of an echidna and the spines of the platypus. As unfamiliar. Okay, so we have create agent trigger, right? And ladies and gentlemen, we're going to do something we've never done before. Something like riding the duck-billed platypus. So we're going to go and we're going to set it to be a trigger type of condition. Trigger type of condition. And this condition will be, anyone want to guess on what it will trigger? Population to be rendered into agents is greater than or equal to 1.0. What's this population to be rendered into agents? It's this stock here. Okay? Okay. Okay. Just giving this some space as befits. It's the dignity bestowed to it. Okay. So we created an event. We made it conditional. It will fire under this condition. Wow, that's interesting. As different, perhaps, as the spines that protrude from the platypus's paws.
Only the back one.
Only the back ones. Back claws. Thank you. Yeah. I'm looking forward this weekend to making their close acquaintance. They'll hopefully separated by glass. And I don't mean the back claws in particular. But, okay. So, ladies and gentlemen, this create agents trigger. What's the function of an event, folks? So it fires, and what's supposed to happen when it fires? It needs to do something, doesn't it? So we need to associate an action with it. And this is going to be the rub here, folks. Ready? Are you ready for this? This is the wee bit of discomfort. Less venomous, for sure, than that creature. Okay. I'm going to create something called a variable. I'm going to say int space count agents to be created. This is giving a nice name for some quantity. I'm going to give it a way to sort of compute a quantity. I want to remember it with this nice name. Okay? Count agents to be created. So this int space count agents to be created. That means there's an integer variable called count agents to be created that I can compute. Now, I'm going to put a formula for it. Int, this means basically treat the value that's computed by the next thing as an integer. Floor of population to be rendered into agents. Okay, that, and then I want to put a semicolon there. So what I'm doing is I'm taking, however many are here, I'm taking the floor of it. What do I mean by floor? So it's supposed that there were so system dynamics operates, these stocks, they operate in terms of continuous quantities. So there might be 2.3 people in population to be rendered as agents. And the agents, I don't have the option of representing a 0.3 person. Can't represent, a couple hairs of the head of that person alone. So we're going to either create 0, 1, 2, 3, 4, etc. agents. And what do you think floor means? Well, if we're given 2.3, what does it give back? 2. It's as simple as that. If it's 2.99, we'll still get back 2. But if it's 3, it'll be 3.
Because you're casting it in dreams, you don't really need it.
Sorry?
You're casting it in dreams, you don't really need the floor.
I don't need the floor?
Yeah.
I know, but I like to be explicit about it. I like to be explicit that it's flooring it. You can cast the double to be an int, and I considered that. But this makes it very explicit that it's taking its floor. But you're right. I agree with you. Okay, fine. I think what I'll do is I value exploration of novel things. So I'll do this, and if you folks are comfortable with it, I'll be comfortable with it. All we're doing is we're taking the integer part of this. Are you okay? Okay, no one seems to be throwing conniptions, so that's great. Okay, so that was horrible. but more remains. Okay, next, ladies and gentlemen, we're going to do this. For int I equals 0, we're going to basically go for each of the agents to be created. So I less than count agents to be created. Okay, yeah, I know. You want it this way, don't you? Yeah, fine. So we're going to create a for. What is this, ladies and gentlemen? It has an L, two O's, and a P. Good, yeah. Where I only got precocious at your age. Okay. This might look weird. We're going to basically go through, we have I equals 0, and as long as I is less than the count of agents to be created, we're going to do whatever's here, and then we're going to make I one bigger than it was at the end, and we're going to, and we'll come back around. We'll see, okay, or similar. So this will go through the loop, and it'll execute it each successive thing in turn, I times. Oh, Dylan, in Java 8, is there a way to do this all in one line for beautifully? Yes,
it's far uglier than you.
That's what I would think. Yeah, it's not beauty. It's not a paragon of beauty.
This is the simpler way to do it.
Yeah, I know, but it still troubles me.
Could be better.
I wish I didn't have to show this to them. But
you could be like arrays dot from.
Yeah, I know. Yeah, I know. It should be really nice, right? Because all I want to do is execute the body n times. I don't even have to care about I and so on.
Well, Java's always been a clunky language. This is what we have to work with.
Indeed. Okay, ladies and gentlemen. Then what we're going to do is we're going to do something we haven't done before. Add our population. Oh my gosh. We're going to add someone with a certain birth time, initial diabetes state, initial weight state, and mean time to adjust physical activity level. Okay, fine. So we'll add someone with all those characteristics. And again, we might draw these from a distribution. So I think we had an initial age distribution, so we're going to use that for their birth time. Oh, sorry, minus the initial for their birth time. And then we're going, you notice this, it tells me what it needs, an initial diabetes state. I'm going to make them initially at a diabetes state, which is glycemic. Now, to do this, I need to do, I can just do it normal glycemic because it's an option list. It's a thing of beauty. I don't have to worry about person dot. That's pretty sweet. Okay. Next, it needs the initial weight state. You notice, by the way, I'm going up here, I'm pressing Control Space, and I'm selecting it with these arrow keys. I'm selecting the one I want, and I'm saying, okay, birth time, initial diabetes state, initial weight state. Ladies and gentlemen, you tell me, what weight should this be? If they've undergone something because of incidence of overweight, in what weight should they be added? If they were normal and overweight, and now they've been subject to incidence of overweight, they are now what? Becoming overweight. So we're turning them in, we're making them overweight agents. When we're creating them, they are already overweight agents. And then it says mean time to adjust physical activity. Okay. Yeah, we'll make this, I should have made that a parameter probably in main, but I'll make it 0.5 years, which was the default value we used for it. Really, I should have taken that out of person, so every person doesn't demand it. Okay, so here we've added them. Why have I lined it up this way? It's just so that I can see each of the arguments in turn without them stretching over off the line here. So it allows you to use multiple lines, and it's often nice to line things up so you can kind of see with each successive one what's being used. Okay, we're just about done here, and then we'll reflect on what we have wrought. Okay, the next thing we're going to do, watch this, population to be rendered into agents. Oh, okay, you want it? Okay, you want that? Okay, that's okay. I'll do it. Yeah. Fine. Okay. Yeah. And then we want to do this. This is the final coup de grace, although it may not be obvious, but Dylan will appreciate this. Create agents trigger dot reset. Or sorry, restart, excuse me, restart. This will get it ready to fire again the next time this condition is true. So ladies and gentlemen, slowly over the course of decades I'll learn to juggle. Okay, so who's copying this down still? Okay, do you want me to put it up on the big screen? Would that be helpful? You can read it? Okay. I was thinking for this weekend of, I came very close to purchasing image stabilization binoculars so I could observe the majesties of the southern constellations this weekend. But judging by the weather this morning, I'm not sure that even the best image stabilization would have helped much. And I think it's yet to be determined whether I'll enjoy the fair acquaintance with the Southern Cross and the large melangelic cloud. I'm told you have a finer nebula than Orion, and a more spectacular globular cluster even than that in Hercules. But that may have to wait to a further trip. Someone suggested I climbed. This is not someone in the class. Incidentally, suggested I climbed to the top of the Sydney Bridge to do stargazing. I have an astronomical companion who had done that in the States and suggested that might be one place to observe the stars, but with a harness on, of course. But I'm going to demur on that. Yeah. Okay, so are people still copying this, or can I explain it now? Okay, so what's going on? Under what conditions is this event triggered? So this is an event, and it goes off. Under what conditions does it go off? Does it fire? Under what conditions is it triggered? That's right. So if there's at least one person, one whole person, to be rendered into agents, this will fire off. And what's the job of this code beneath it? This is a bunch of plumbing. And I dislike having to drag you through this too. But in the scheme of things, it's not the very worst thing to which I've ever subjected you in our brief acquaintance of a week. So what is this code doing? At a very high level, what is it doing? What is it accomplishing, putting aside for the moment exactly the how? Well, it's figuring out how many agents to create, and then it's going through and adding agents with those characteristics. And then it's sort of decrementing all those agents so they don't have to be created later from the stock. They were waiting in that stock to be created, a count of them. 57 agents in that stock awaiting creation. So we go through, we say, 50, maybe there's 57.23 waiting creation. We say, how many agents are we going to create? 57. We can't create a 0.23 agent. They'll often wait till more gets accumulated there. So the 57 agents will go through one by one, just like that, in that for loop. And we'll create each of them in turn, and we'll get to the details of that in just a moment. And then we'll take this population to be rendered age at 57.23, and we'll deduct from that, we'll remove from that, we'll take out of it the 57 we created, leaving how many agents? There were 57.23 that it says there are weights, and we actually created 57, so how many will remain? We created 57 of them, and it had requested 57.23, so how many will remain? 0.23 agents, this partial request, which more will flow in later, and it will fill up to at least one probably. So we leave 0.23, so we noted basically that we had created the 57, and then we reset this, so the next time this is true, it'll fire again. The next time it goes above that level, it'll fire again.
So now, is that happening in continuous time or every
Yes.
1 year time?
No, it's happening in continuous time. Yeah. So if things are flowing into you really quickly, this will happen frequently. If they're flowing in slowly, it will happen slowly in continuous time. Okay, now, as for the details, this add population, I didn't have time, and I regret to tell you, unless there's a mass revolt, an uprising, unless there's that Nate cage that's being prepared, I'm not going to have time to go into open populations. I cover them really well online, and we don't have to go into them in detail. But this is how you add people to a population. You call add population, and this is the characteristics of the people to be added. What are these things that I'm specifying here? There are the values of the parameters of the agent. First is the age, and we draw that from an age distribution. This would really be the age distribution for, specifically for overweight people. But I don't want to take the time, because time is a fleeting, and that will have an opportunity cost. They start normal and glycemic. You could really say, okay, what fraction of people who are starting overweight or diabetic, I'm treating it as minimal here. They're overweight because the reason we're capturing this way is they're becoming overweight. And then they are, and then we're saying there's a mean time to adjust weight of 0.5, which I really shouldn't have left as a parameter of a person. I should have made a parameter of mean. Okay? Okay, so that's the basic mechanism here. Are you comfortable with that? There's only one thing to do. This is the basic deal. There's only one thing that remains between you and your break here, and that is me. Well, no, and that is here this initial distribution that we had created for. If we go here, it's under in main. It's this thing. Sorry, it's not analysis data. It's the custom distribution for the initial weight distribution, because initial weight distribution had a large number of people being created who are normal glycemic, and we don't want that anymore. We don't need to represent them as agents initially. Why not? We're going to make the initial weight distribution for normal and underweight be 0, because this is for creating the agents. And sorry, wrong variable. Thank you, Joe. Normal and underweight will be 0. Oh, okay. It's acting finicky. Okay, there we go. So I just made it normal weight for the initial weight distribution of agents. Agents to create will be 0, because where will normal and underweight individuals be captured? Whither will they live? In Maine as a homogeneous population in that stock, no less. They will be placed in the stock. Not in the same sense that my ancestors were placed in stocks, but in this stock they will be trapped as numbers in that stock. And at the time that this says becoming at risk, let's give that a better name. Let's say becoming overweight. Should we say it? Should we not say it? It'll be more transparent. Okay, becoming overweight. Is that okay, folks? Can we run this now? What do you think we'll see?
An error message that you changed the name?
Oh,
I'm guessing.
no? No? I just called it becoming overweight. It's pretty good at automatically updating names here for that. Call it becoming overweight here. Okay, build. Okay, Dylan stands ready. Dylan sits ready.
Sorry, can you just go back to, you called it something else, what was it?
Well, it was called becoming at risk, and I just changed it to be called becoming overweight, just to be more.
Is there an easy way, it's really difficult to find things on the actual screen, is there an easy way of actually being able to find pages to repeat them?
Okay, there's great question. There's two ways. I'm not sure either of them will qualify as easy, but we'll let me present them. There's one way over here in the projects. If you go like into the system dynamics area, it will list all of these. And like here will be becoming overweight. You could click on it, it will bring you to it. So that might not be so bad. The other way that's quite easy is to do this. You do Control F to search. Alternatively, you can press this button here, which looks like a flashlight, and you could search for, say, becoming, and it will show you various places where this is referred to in the model. And by clicking on that, you'll be brought to it as well. So those are two ways of sort of going and finding things beyond kind of casting around and looking. Okay? Okay, sure. Okay, let's run this model now. What should we see? What should we see? What should we see? Well, if I had more time, I'd make it more beautiful. We should see some initial agents, but then we should see some agents coming in, actually. You notice that this population is going up. The population is actually rising. 276, 283, 287. Let's make this more obvious by making it the baseline population be something much smaller. This is part of the issue. I don't have time to sort of go make really nice here. This is currently the agent population size. So I'll make it a population size, say, of 10 agents. Watch this. 10 agents, and I'll run it in the experiment, and there we go. And who's this coming in? People becoming overweight. They were where? They were in this stock up here, were they not? But they're becoming overweight over time. The stock is dropping as they are becoming agents. Now, there's just one final thing that is needed if we want to, oh gosh, okay. If we want to do this, there's just one final thing. After we add this population in one by one by one, actually what we should do is we should say apply network. This is in the event after adding the population, and that will knit people together into networks. So then they'll be joining the network rather than being disconnected. So I'm going to try this again, and I'd like you to invite you to look. See that? They're joining it. You see that? As they become at risk, they are joining this. So how did I do that? Apply network. I just did it right here. Boom. Excuse me. I was going to, oh gosh. Okay. There we go. And that's it. Okay. Hey. There we go. Hey. And okay. Apply. Can you see it from back there? Apply network. Yeah. Apply network.
So mate, we have people's size in the display based on their weight, don't we? Like, so if they were small, that meant they were normal weight.
I'm trying to think.
And in which case should we not see any small people if this was
Yeah, it's a good point. I'd have to go back and, because we went through several. We had at least two different ways of displaying. people's size. Let's go see what it is. It's based on image scale, and image scale is
So the small people are age
right.
Yeah.
Yeah. Yeah. So when they entered this, the image scale should have been 2.0. So if they come in as overweight, so I would have expected when they get added as overweight individuals, they would have gotten added not as the very smallest icons. So like here, let's start this again. Yeah. Okay. So okay, there are people who lose weight still, but it looks like I've yet to see anyone being added who's small, but we'd have to maybe there are, but sometimes they lose weight too. Okay, so what we have here, folks, is a hybrid model. We have a model where we have an upstream population in stocks, and they flow down to the point where they become agents. It's not too bad to do. I didn't have time to do it full justice, dividing the initial population between the stock and the number of agents, but that's a little bit of fairly straightforward stuff. But hopefully that gives you some sense of that hybrid approach. Okay, this approach where people become agents after being in stocks. Okay. So that's all for that component. We're going to have a break right now, and then we're going to return, and we'll be going on to the next major topic. Okay? Sensitivity analysis and calibration. Great.